So today is the second lesson on the normal distribution. Last lesson we looked at the main features of the normal distribution, and we also worked out how to work out areas under the graph of the normal distribution, or under the curve of the normal distribution, by memorizing the areas that you get within 1 standard deviation, 2 standard deviations, 3 standard deviations. And those values we didn't use a calculator for. Today we're going to be using a calculator. Most of you are going to be using the Casio ClassWiz calculator, and the code for that is the FX991EX. Yeah, some of you may be using the graphics calculator that you can get. Now if you're going to be using this calculator and you want to access the menu that allows you to work out the normal distributions, so first of all press the menu button, and that menu button is right next to the on button at the top. Once you press menu, you can scroll down and scroll across to number 7, or you can actually just press 7, and there's like a picture of a sort of normal distribution there. Press equals, so we use equals like enter. That'll take you into like a little sub menu, and you'll see a range of options there. Now you would have used this already with the binomial PD and binomial CD. We're going to be using the the normal CD, because we want the cumulative probabilities, and pretty much literally every question that we do, we're going to be using the normal CD. Now if I press that and go into that menu, you'll see you'll be presented with some options. It will say lower, and it's waiting for you to type a number in. Upper, it wants you to type a number in, and then it will have the standard deviation, it's waiting for a value for that, and the mean. Yeah, so that's the values it's looking for. So with our normal distribution like this, if we wanted to find a particular area, let's say the area was between those two like that, then your lower value is going to be this one here, your upper value will be that, and then the mean and the standard deviation, well, they're whatever is given in the question. Just watch out that when we write down a normal distribution, remember the two parameters, the two numbers you need are the mean and the variance. So take care that whatever number you see in that bracket, you square root it, the positive square root, to get the standard deviation. Yeah. So once you're in that menu, you can pretty much use that to work out these areas, because they're not going to be maybe 1 standard deviation or 2 standard deviations from the mean. They can be any values. So we use a calculator for that, and in fact you'll probably find these easier to work out than when you do the binomial, because with a continuous distribution, if you have this symbol or this symbol, you do exactly the same thing. If you have this symbol or this symbol, you do exactly the same thing. That's not the same with binomial. You'll need to sort of move things around a bit and make a little bit of a correction, because you're dealing with discrete numbers. Here it's continuous. So whichever one of those symbols you see, so if you see those two, either one of those two, you do the same things. If you see they're the same, do the same thing, we do the same thing. Yeah, so it's slightly different. Right, let's look at some examples here, and here it's asking us to work out these values here. So you can see it's a normal distribution. X is what we call this random variable. N stands for normal distribution. You can see here that the mean is 30 and the variance is 4 squared. So if I'm doing any one of these questions, the first thing I'll write down is what the parameters are, so I don't make any mistakes. So I'm going to have the mean is 30, the variance is 4 squared or 16, and the standard deviation is 4. So I'd always write those things down so that I don't type the wrong things in. So part A, it's saying find the probability that x is less than 33. Now, just like I said before, if this said x is less than or equal to 33, it would not change the question. You would do exactly the same thing. It's not going to change our working, okay? And whenever I do questions like this, I always do a diagram so I can see exactly what it is I need to work out. So I'm just going to draw a normal distribution here. The mean is 30, so the mean always goes in the middle. 33 is here because it's bigger than 30, and it's less than 33, so I'm just going to shade in the area that I'm trying to find. So I'm trying to find that area. So straight away I know that my answer should be more than 0.5 because it's more than half the area. And if I get an answer less than 0.5, I know I've done something wrong. So in the same menu, my lower value, right, you can see there is no lower value here because this tail, remember, it goes on forever. So what do we choose as a lower value? Well, anytime you're not given a lower value, so let's say we've got an open-ended lower, or it could be an upper value or upper value, then you need to choose an upper or lower value, and that upper or lower value, so you choose an upper or lower value at least 5 standard deviations, above or below the upper value. Yeah, so our upper value is 33. If a standard deviation here is 4, so 5 times that is 20. So my lower value needs to be at least 20 less than 33. Now, you don't have to keep working out 5 standard deviations less. Just pick a number way below that 33. So as a minimum, my lower value should be 20 less than 33, so 13. But I would choose a lower value of maybe 0, because you know that's going to be at least 5 standard deviations away. So you can just pick a really small number, a long way away from this, or a really big number. But at least 5 standard deviations ensures that you're basically getting right into that tail, and you're to 4 decimal places, you're going to get an answer that's pretty much the same. There's hardly going to be any difference. So I'm going to choose a lower value of 0, an upper value of 33, standard deviation of 4, and a mean of 30. And if I do that, press equals twice, and I get to 4 decimal places 0.7734. So 0.7734, okay, because it was 337. Now, what if I chose my lower value as 33 minus 2013? Would that have made any difference? Okay, so I just need to press AC on my calculator to get back to the menu. I'm going to change the lower value. You can try this as well. I'm going to change it to 13. I'm going to put lower value 13. See what happens. 0.7734 to 4 decimal places. So to 4 decimal places, it's the same. So that's fine. We don't need to worry about doing 13 instead of 0. Yeah. So either way, as long as when you go back this way, if it's open-ended, at least this 5 standard deviations away. Okay, let's have a look at part B. So part B, the probability that the random variable x is greater than or equal to 24. So again, I'm going to draw a diagram. Always draw a diagram on these questions just to make sure. And we still the same mean of 30. 24 is over here. And greater than or equal to 24. All right, remember the last one we said we were expecting a value greater than 0.5 because we said it's more than half the area, and we did get that, didn't we? Yeah, that's more than 0.5. The same with this one. Greater or equal to 24. If it was greater than 24, I'd do exactly the same working. So here we have an open-ended upper value. So there's no upper value given. But I know it needs to be at least 5 standard deviations away from 24. So it needs to be 24 plus 20 to give me 44. So that's the minimum value. So again, at least these 5 standard deviations. But in practice, if I just chose a big number way above 24 as my upper value, it doesn't make any difference. So I'm going to choose and go back. I'm going to do my lower value this time is 24. I have the lower value. As the upper value, well, it needs to be at least 44. I'm just going to put 1,000 in. Yeah, it doesn't really make any difference. Just a number far enough away from 24. Same mean and standard deviation as before. And I get 0.9332. And that is to 4 decimal places again, 0.9332 for that one. Okay, C. So on part C, I can see, you can see in C, that it's between 2 values. So I have, it's between 33.5 and 38.2. So I'm going to draw a diagram again. You'll do lots of these in this chapter. And it's between 2 values. Now remember, 30 is in the middle. And it's between 2 values that are actually higher than 30. So it's over here somewhere. Yeah, it's going to be something like that. 33.5 and 38.2. I'm expecting an answer less than 0.5 because that area is less than 0.5. So this one, I do know the lower and upper value. So the lower value is 33.5. The upper value is 38.2. Same standard deviation and mean, and I end up with an area of 0.1706. 0.1706 for that one. And last one, D. Between 27 and 32. So let's draw this one. Now you can see this is much easier than binomial, because with binomial, if you were doing it between numbers, you'd have to work out, I'm going to have to draw a better one than that, that's awful. If it was between 2 numbers, you would have to do all sorts of, I don't know if that's any better really, you'd have to do all sorts of different things. You couldn't just type in a lower and upper value. Right, 27 is below 30, 32 is above 30. They're not both the same distance away, it's just my drawing. So we're working out an area like that. Now we don't know whether this is more or less than 0.5. really. We'll have to work it out. So we're trying to find a probability. Oh, actually, let me redo that question. It would help if I read it properly. It's not between two values. It is less than 27, greater than 32. Less than 27 and greater than 32. So that would help if I read the question properly. Right, so let's draw that out. So it's not going to look like what I said it was going to look like. I lied. 30 in the middle. 27, 32. So actually the areas I need to find are in these two tails here. Now, this is two areas. I've got two ways of doing this. I could find the area from a very small value up to 27, and find the area from 32 up to a very big value and add the two together. Or, since the area under this curve is equal to 1, I could find the area of that gap in the middle and do 1 minus that, because it's quite easy to find the area between two values. So I'm going to find the area of that bit in the middle, the gap. And that would be a lower value of 27, an upper value of 32, same standard deviation of mean, and I get an area of 0.4648. Now that's the area of the gap. I want the inverse, the other area. So if I do 1 minus that, I get the area of the bits in the two tails. Unfortunately, on these class quiz calculators, if you want to go back and do a normal calculation, there's no easy way. Now, what I've just done, that number is stored in the answer button. So I'm going to have to go back to menu, choose number 1, and I'm going to do 1 minus answer. So I don't need to memorize the decimal, write it down again. And if I do that, I get 0.5352. That's rounded to 4 decimal places. Yeah? Now that is a quicker way of doing it than finding the area from, I don't know, 0 to 27, and then from 32 to 100 and adding the two together. You can do it like that, but on the class quiz calculator you'd have to keep flicking backwards between one mode and the other. So sometimes on a question it might be easier to find the area of their gap. So let's highlight the area we actually found. So we found that area there in purple, and then we did 1 minus that. Okay, so here we're applying normal distribution to a question. It's about an IQ test, and they're found to be normally distributed. So that information is here. We've got the mean and the variance, and it says that if they get more than 140, they're classified as genius. And part A says find out the probability that an adult chosen at random achieves a genius classification. So first thing we're going to do is we're going to write down the mean. We're going to write down the variance, and we're going to write down the standard deviation. So always write those things down, and then the other thing that we always do is to draw a diagram. Okay, so there's my badly drawn normal distribution with a mean of 100 in the middle. Geniuses get 140 or more, so I want to find that area there. So I know I'm expecting an answer less or than 0.5. Okay, so we're trying to find a probability that they get more than 140, or we could put more than or equal to. I'll put it in a different colour, just to show that this is optional. That makes no difference to the answer. So on our calculators, menu 7 and number 2, normal CD again, lower value of 140, an upper value, this is one where there's no upper value, so I can choose anything I like. So I'm going to choose 1,000. That's more than 5 standard deviations away. So it would have to be 5 times 15. It'd have to be more than 75, more than 140. So I've chosen 1,000. That will do. I've got a standard deviation of 15 and a mean of 100. So I'm just going to type those things in and press equals. And I get quite a small answer here. It's 0.003. Yeah, mine actually gives the answer to standard form. So 3.830 times 10 to the minus 3. Okay, which I'm pretty sure is that 1, 2, 3. Yeah, put the 0 there, so we got okay. Right, so that's part A done. Now part B, 20 adults take the test. Find a probability that 2 or more are classified as genius. Now this is where some students get confused, because they think, right, I've just been doing normal distribution, so part B must be normal distribution, but it's not. We have a sample size of 20 adults. We want to find that 2 or more are classified as genius, assuming that the probability of being a genius is independent, so me being a genius doesn't affect you being a genius. This becomes a binomial question because we have a sample size and we have a probability of success which is fixed, and we're looking at 2 or more here. So because this is a binomial question, we shouldn't really put X is a binomial distribution, because we've used X for the normal distribution. So we're going to use a different letter. Let's use Y. So Y is binomial distributed. N is 20, that's my sample size. And the probability of success is what I've just worked out in the last bit of the question. So 3.83 times 10 to the minus 3. This quite often happens. In part A of the question, you work out a probability, and in part B, you use that probability in a slightly different context. Binomial here. Right, okay, and we want to find the probability that we have 2 or more are classified as genius. Now we're going back to a discrete distribution, so that can't be worked out directly. So that's going to be 1 minus the probability. So if it's greater than or equal to 2, then we need to work out less than or equal to 1. So this is where we go to our calculators, menu again, 7. This time we want binomial CD. So you go on the second page of the options in the sub-menu, and we choose 1. We want a variable, number 2. So X, in this case, is going to be 1. N is 20. P, now we should be able to press the answer button if the last thing we worked out was that probability, and just press answer, or you can type that probability in. Yeah, if you press answer, press equals, then you'll see that probability that we've just used pop up, and that is, and I need to do 1 minus that, so I need to go back to my menu, number 1, and do 1 minus my answer, and I get 2.66 times 10 to the minus 3. Okay. So the probability that 2 or more are classified as genius should be this value here, which would be 0.00266, okay, as our final answer. So just to recap on that second one, 20 adults take the test, so that's our N. The probability of success, probability of being a genius, well, that was what we worked out in part A. We want to find a probability that more than 2 are classified as genius. We'd expect it to be quite low. So we have to do 1 minus the probability less than 1 if we want to find more than 2 out of the 20. So on our calculators, we can put in those figures. So X was 1, N was 20, and the other values that we needed were P as well. So I'll just press the answer button because I just worked that out. And once we've done that, I think there was one more. No, X, N and P, that's it. Yeah, and then we got our answers for that one. Right, so you should now be in a position where you can do exercise 3B on pages 43 to 44.